our proofs unit. Proofs are going to follow us around for quite a while. So we're going to start off with like the basic vocab, as basic as we can go. I got 3 boxes here. The first box represents all of the properties of equality. These are all vocab terms that we need to know and be able to use. They do appear on that little Unit 2 extra credit vocab thing. So all of these can go onto your flashcards. This first box represents my properties of equality. So properties of equality are always going to involve equal signs. So we will see that in all of these. And the first 4 that we're going to talk about are all things that we do all the time when we are solving things algebraically, but maybe we didn't know that they had names originally. They do have names. So the first property of equality is the addition property of equality. We have to use that entire name when we talk about it. The addition property of equality literally states that I can add the same thing to both sides of an equation, and that equation will remain the same, right? I didn't change anything. I added the same thing to both sides of an equation. We do this all the time when we are solving things for x, right? If I have an x on one side, like x plus 5 equals 7 or something like that, like I would add, well, I wouldn't do that. Because x minus 5 equals 7, I would add 5 to both sides, right? That's my addition property of equality. And the same thing goes for all the rest of the operations. The subtraction property of equality says that I can subtract the same thing from both sides of an equation, and it remains true. The multiplication property of equality states that I can multiply the same number to both sides of an equation, and it remains true. And the division property, as long as we are not dividing by 0, I can divide both sides of an equation by the same number, and it remains true. Those are just like my algebraic properties. We do those all the time and just don't even realize what we are doing has a name. Another algebraic property, this one is just simply called simplify, so it doesn't have a big long name. And the simplify property literally states if I have a plus a equals b, then I can simplify that to 2a equals b. Now we have a name for this. Do we remember what this is called? Anybody? This is called combining like terms. So anytime we see something where we combined like terms, that is the simplify property. Any questions there? All algebra topics, just things that we do all the time. Next, I have some weird ones. These are like where I'm going to get nitpicky. So the first one that we have here is called the reflexive property. Again, reflexive property of equality, because I see the equal signs in here. And the reflexive property literally states that something equals itself. That's as basic as it gets. A equals A, it equals itself. True, right? I'm not arguing that. The symmetric property is kind of the same. It says if A equals B, then I can reverse it like I'm looking in a mirror. I'm mirroring it. So then B equals A. I flip those two things around and it is still true. So that is like our mirror property. Keep in mind, it is not reflective property, it is reflexive property. So don't think reflect like a mirror for that first one. Symmetric is our mirror property. Questions on those two? Those two kind of get mixed up a lot, so we want to make sure that we understand the difference between reflexive, it equals itself, symmetric, we can flip it around like we're looking in a mirror. The next one is the transitive property. I call this like the middleman property. Okay, in this property, we say that one piece, A, is equal to B. B is equal to C. So those two things, A and B, are both equal to the same middleman. That middleman is B. So we can cut out the middleman, and we can say simply that A equals C. Oops, middle. Man, I didn't finish writing that. So that is our transitive property of equality. Questions on that one? The last one here in this box is the substitution property of equality. This one says if A equals B, then we can replace any A in an expression with a B. That's literally all it says. So A equals B, then B can replace wherever I have an A. So this is like if you get an equation like x plus 5 equals 7, I can say x equals 2. I can replace x with 2 in that equation, right? That's substitution. Okay, questions on this first box. Those are my properties of equality. They all say property of equality in their full title. The only one that doesn't is simplify. It's literally just called simplify. The next one, again, one that we use all the time but don't really name too often, is the distributive property. Another algebraic property, it says that if I have something on the outside of some grouping symbols, like A times B plus C, I can multiply that A to every piece inside of my parentheses to get A times B plus A times C. We've used this before, yes, I'm not telling you anything crazy. Okay, and then my last box has to do with all of my properties of congruence. So we are going to see a lot of the same properties that I just mentioned, except the difference here is that I am not going to see them used with equal signs. I'm going to see them used with congruent symbols. That was not a good squiggle. So my congruent symbol is the equal sign with the squiggle on top. So that is how we tell the difference between a property of equality versus a property of congruence. So we see the reflexive property of congruence states that a segment is congruent to itself. An angle is congruent to itself. That is the reflexive property of congruence. The next one is the symmetric property of congruence. Same idea as the symmetric property of equality. It states that if I have segment AB congruent to segment CD, I can mirror that statement and say that segment CD is congruent to segment AB. The one thing that gets tricky when I talk about properties of congruence is that we're usually talking about like parts of a diagram, angles, segments, lines, things like that. When we name angles, segments, lines, we know that there's multiple ways to name the same thing, right? So if I draw out a segment here, and let's say I call this segment AB. If I write a statement that looks like AB is congruent to BA, do we think that that is an example of the reflexive property of congruence or the symmetric property of congruence? Any ideas? Take a wild guess. No one wants to give it a shot. Okay. This right here, this is a trick. They try to trick you all the time with these two because they kind of work together. This is an example of the reflexive property. I'm saying that segment AB is congruent to itself. I just changed the way I named that same exact segment. If I am saying something is congruent to itself, that is always the reflexive property. Okay? I know we switched those letters around, so it's tempting to say, oh, that's mirrored. It must be the symmetric property. But the symmetric property specifically deals with two different pieces. AB and CD are two different pieces. Whereas this right here, AB congruent to BA, is just one thing. One of the same exact thing. So those two are tricky. Don't let it trick you. This is reflexive. Oh. I didn't know I could do that. And then the last one here, again, one that we've seen already, the transitive property states that if I have AB congruent to CD and CD is congruent to EF, then I can cut out that middleman, which is CD, because they are both congruent to CD, and say that they are congruent to each other. Same idea as the transitive property of equality, except we have congruent symbols instead. Any questions on that? No, we're okay? Okay, so let's look at the examples. I'm going to be given a statement, and I want to give a reason. My reason is going to be one of these things in my box. Statement says, if x equals y and y plus 4 equals 3x, then x plus 4 equals 3x. Any ideas on this? What do we got? Pull sticks? Nobody wants to give this a go? Caitlin, what do you think? Give it a guess. What would you say we are adding to both sides? No, we're not adding 4 to both sides. Somebody else? Gabby? Yeah? Yeah, it is. We're substituting. We're saying x equals y. So I have a statement that has a y in it. I'm going to replace it with an x. That is my substitution property. Substitution property of equality. I know it's equality because it has equal signs. What about a number 2? What do we think for number 2? Casper. What are you adding to both sides? What are you subtracting from both sides? Yeah. In this statement, it's literally like algebra, right? X plus 4 equals 3x. Think about how you would go about this problem. Obviously, you're subtracting x from both sides to get 4 equals 2x. That is my subtraction. We have to use its full name, subtraction property of equality. What about number 3? Any guesses on that one? Gabby? Property of what? Equality or congruence? Yeah, I see congruent symbols. It must be congruence. I'm cutting out that middle man. P is congruent to Q. Q is congruent to R. Therefore, the 2 on the ends, P and R, must be congruent to each other. Any questions on that? Okay, flip it over. First one here, number 1. The measure of angle DEF is equal to the measure of angle DEF. What do we think? Angelina. The measure of angle DEF is equal to the measure of angle DEF. What do we think? Give it your best guess. Reflexive property of... Is there a congruent symbol in there? Property of equality. So it is equal to itself. That's reflexive. Number 2, maybe a trickier one in number 2. The measure of angle A equals 45. 45 equals the measure of angle B. Then the measure of angle A equals the measure of angle B. Think about how many different parts I have here. I have angle B, I have angle A, I have 45. Anyone want to give it a go? Leah? Best guess? Best we can do? Symmetric property. Not symmetric. Somebody else want to give it a guess? Allegra? transitive. We're cutting out this middle man. 45 is equal to both of those things. Then we can say the 2 on the end must be equal to each other. This is the transitive property of equal signs, so equality. Number 3, if KL is congruent to MN, then MN is congruent to KL. What do we think? Casper? Yeah, symmetric. They are flipped. They're mirrored. KL congruent to MN. We flip the order. MN congruent to KL. This is the symmetric property of perfect. Number 4, what do we think? I see algebra happening. They're doing something to both sides. What are they doing to both sides, Casper? Adding what? Yeah, add 5 to both sides. I'm going to write it out for us. If I add 5 to both sides, those 5s cancel out. I get that final statement, SY equals RT. So this is the addition property of equality. What about number 5? Segment YZ congruent to segment ZY. Anna. Why is it reflexive?
Because it's still YZ is congruent to YZ.
I'm talking about one segment, YZ. I changed how I named it to ZY, but it's the same exact segment that I'm talking about being congruent to itself. That is the reflexive property of congruence. Okay, a couple more here. Number 8, I'm on number 6. AB equals AC plus CB, then AB minus CB equals AC. There's a lot going on in here. Sometimes it's helpful to write these out like I've been doing to kind of see what the algebra is that's going on inside of here. So AB equals AC plus CB. I want to end up with AB minus CB equals AC. So that means I went from this to having AC alone on this side. Think about that algebraically. To get AC alone on the right side, what did I have to do to that? Caitlin? Yeah, subtract CB from both sides. That means if I'm subtracting the same thing from both sides, that's the subtraction property of equality. Number 7. What do we think there? What are we doing? Anna?
Division property of equality.
What are you dividing by? Perfect. Oops. For something like this, I would also take multiplication property of equality. If I said this is the multiplication property of equality, what would I be multiplying both sides by? Allegra? Yeah, I could multiply both sides by 1/3. I could divide both sides by 3. Those are essentially the same thing, right? Okay. Number 8, one of our weird ones, not one of those common ones. It had its own little box, Casper. Yeah, this is just the distributive property. Oops. We actually don't even need to write property of equality or property of congruence. It's just the distributive property. Let's see. Is there a weird one that I want to talk about? No. I think we're okay. Oh, what about 13? What's the last one on here? Sorry, I'm skipping around. What's number 13? Yeah. Why does it simplify? We are combining these like terms. Anytime I combine like terms and then don't do anything else, that is the property literally just called simplify. Any questions on that?